Zindi hackathons. This time with focus on last year's Yango hackathon. So in today's presentation, it will be more of a call to action presentation where you'll be able to watch this video and directly work with the notebook. So to start with, we are going to be using Google Colab as our IDE for this presentation. So I think, can I share my screen?
Yeah, you should be able to share.
Okay, is my screen able to be seen?
Yes.
Okay, so yes, just as I said, today will be more of an introductory to get it started with Zindi challenges. And in today's presentation, this is a call to action, meaning that it's hands-on practice. Whatever we'll be doing here, you can test it out directly. And if you have your PC with you right now, or just anything, any type of device that can manage to do this, you can follow along in the video, especially if you're a beginner and just getting started. So as I said, for today, we will be using Google Colab as our IDE. So Google Colab is something by Google that is an IDE by Google that helps us run notebooks. So it makes things easier because I'm assuming almost everyone has a Google account. So we're going to search for Google Colab, just spelled the same way when you're spelling the word collaborate. Now the short way of collaborate. So when you search Google Colab, you'll find something saying welcome to Google Colab. So what you can do is click there. So once you click there, you will come across something. You're going to come across something like this. You come across something like this. Welcome to Colab, and these are some new things, features added by Google Colab. And then the next thing that we are going to do is now we're going to head to Zindi. Yeah. So when we head to Zindi, we are going to go to the challenge which has been brought in by Yango. It's a knowledge challenge, and I'm sure the link has been sent to everyone. If it hasn't, you can write either in the comments or in the search. Okay. Just a minute to find that link. Okay, I'm just going to stop sharing my screen just for a few just for a few minutes. Okay, so is everyone able to see my screen now? Okay, so I'm assuming everyone is able to see. So yes, so this is basically the practice challenge, Lusaka Yango Hackathon. So what we are going to do when we come here is, if you haven't enrolled to it yet, this part should show you join. So what you're going to do is you're going to click join here, and immediately you join, it will give you some terms and conditions that you are going to accept to be a part of the practice challenge Lusaka hackathon. And then, as I said, this is more like hands-on practice. Exactly the same thing that we're doing here is about the same match that will happen in the hackathon. And I'm sure if you join the other hackathon, it told you some terms and conditions, and you joined. So what we're going to do is we are going to move like we're going to come to the data here. So when we come to the data, the Zindi platform provides us with information that is going to be relevant for us to work with the data. So basically, this here is the information about the data sets. So when we scroll down, we are going to find these data sets, and these are the same data sets that we are going to use to find insights about the data, as well as run and train the notebooks. So what we are going to do is just click on, immediately you click, you notice that it has started downloading. You click on the starter notebook as well. The starter notebook is something that is going to help us to work with the data. I will explain a bit more details about the starter notebook. Immediately we start running the Google Colab. So we do the same for train, graph. You just download everything and try to understand what everything is about. So understanding what it's about is on the point written description here. You can come here, the train contains the target. This is the data set that you will use to train your model. So from this part, you already get a glimpse of what we are going to use to train the model. We'll come here, test. The test resembles the train CSV file without the target related columns. This is the data set on which you now apply the model to, which is more like saying after we create the model here using the training, we'll use the test, we'll now divert that model to the test data set and create predictions. So now, since everything here has downloaded, we are now going to work now hands-on practice to see how these work in a Google Colab IDE. So now what we're going to do is to upload is the same one that was here under data, the one written Yango Starter Notebook. So click upload notebook. And then when we come here, we're going to press browse, and then it should take you to your downloads. So we click on the starter notebook that downloaded. Okay, so the notebook just managed to be uploaded successfully, and now here it is. So basically, as I said, I'm going to explain more about the starter notebook when we get into Google Colab. So the starter notebook is basically something that helps you start the notebook right away. As we've talked about earlier, this is a hackathon, and sometimes you may not have the time to be able to do some things, for example, handle missing values and things like that. So the starter notebook is more of like a baseline that more of like makes you just focus directly on the model, and most of the work is done. But sometimes, in most cases, you have to do things like feature engineering and stuff like that. So now that we have managed to upload the starter notebook, what we have, the next thing that we are going to do now is maybe for the sake of, if you just want to see the notebook like running, if you're using Microsoft uh, computer that runs on Windows, you can just click on this cell here and press Shift Enter, and it should start running. If you're using Mac, I'm not that quite sure, but for the meantime, if that doesn't work, you can also just click on these points here to run the cell and it's going to run. So in this case, we ran this one, and immediately you see a tick there. It means that it has managed to successfully run. So what we are running here is simply we are installing a library. So now we've seen that the notebook is able to run. We can click here where it's written files, this thing that resembles a folder. We click on it. Immediately we click on it, you click on this part that says upload to session storage. So this point now is the point where we are going to upload the necessary information that we got when we came to the Zindi platform. We came on data, and then now we came here where the files are. So we are going to upload some of these here to help us run the notebook, because if we try to run it here, so we managed to run this cell, and then now we run this cell. This cell contains libraries that are going to be necessary for us to work with a notebook. So this cell has managed to run. We run this cell. This is the seed that helps us to reproduce the same predictions. So you notice that when we come to the file paths and then we run this part, it's not able to run because it has said, given us an error here, said no such file or directory called train CSV. So now that's when now the importance of us having to download these files comes in place. So now, let's say now that we've downloaded everything. So we're going to press on the file here, and then when we press, we're going to click this part at the top, which more of like is a paper with an arrow pointing up, or sometimes you might have the files in your Google Drive and you can just access them directly there. But in this case, we downloaded them. So we press here, and in most cases, you download them. So we press here, and once we press here, it will bring me back to my downloads file. So if you can recall, we got in these are the things that these are the files that we got from the Zindi platform. So we'll get the graph file, test, train, as well as the sample submission that we got from the Zindi platform. So press open. I want to ensure that the files are saved also. Okay. So here you will now see this, notice these things here. This implies that now your files are loading and are now being uploaded to your Google Colab. So we are left now with the test and the train, and this even makes sense that we are left with waiting for them to be uploaded, because if you can see, we have 9.7 MB of the train test CSV and 20 with the train CSV. Yeah. So, but basically, it looks like all has loaded. So now, when everything, okay, it still looks like it's still uploading. So we'll just wait for it to upload. But basically now, as we are waiting, what you're going to do is when you come here, you find the train. This is, if we read on top, it's written loading and previewing the data. So what we're going to be basically doing here is loading files. So, in Python, when we have an equal sign like this, it's this equal sign simply means assigning, and then the library that we use for files is called pandas. This one, import pandas as PD. So what we can see here is that we are saying we are assigning train to the train.csv file, and then since it's pandas, we say train is equals to pd dot read the CSV file. So what we're going to do is now we're going to come here, since now all the files have managed to upload successfully, although, okay, the train file is now done. So we'll click here for the train.csv. We're going to click these three dots. When we click these three dots, what you're going to find is download, rename file, delete file, copy path, as well as refresh. So in this case, what we are going to do is we are going to copy the path of the CSV file. So we've copied for the train, and then what we're going to do is just this part written train.csv, not these semicolons. We are going to remove this part and then add the path that we copied from the train CSV. So it should look something like this. And then next we'll come to the test.csv file. We will do the same. We are going to copy, and then we are going to do that. And immediately we do that. We just the same process. It should look something like this. We'll come to the sample submission. We're going to copy the path. And when we copy the path, we'll remove that again, and then we'll do that. So if you can notice, this here looks to have the same momentum on where you're just adding content, but I think that will confuse if I follow that path. We'll just follow copying and pasting. Yes. So now that this has done, and you can now that this is done, and you can recall that when we tried to run this part, it didn't work. So we are now going to run this part. So I said, if you're using a Microsoft, a Windows computer, to run this cell, you can just press Shift and then Enter. But I'll assume I'll be neutral here because I'm not sure for people using Mac. So we'll click this part to run. So you see now that we managed to assign the real CSV files, we are now able to see that it managed to run. And then this here in Python, train.head, means that we are showing the first 5 columns of the head CSV. So as you can see, this is train.head, so meaning that this is the train CSV file. So this is the head of the train CSV files, and we can see it has got a load of variables. But luckily, the starter notebook helps you kind of get more around this. As I said, in a hackathon, you have a limited amount of time, and sometimes you might not be able to deal with such things, because you can see this part is just containing almost, there are no values here. Yes, so basically now we'll move to the next cell here, and we'll run the cell. It will provide us with the the head of the test values. Same applies for sample submission, the sample submission CSV. These are the first, the head of them. And then this is now for the graph. And then we'll move here, train.shape. The word shape it just means it's just showing us the dimensions of the data set. This is the rows and columns. So train.shape, test.shape, and that one. And now we are seeing that. And then this part here is the ratios. So that's the ratio. And then now this part of the this part of the CSV is now where we are getting statistical summaries. So to get statistical summaries, we use the keyword describe just after the word train dot describe, and then we'll go out with brackets there. So when we do that, this helps us describe the data set quickly, because as I said, the data sets are very huge. This is just an example of how big the data set is. So the variables are going all the way this side, and it's coming all the way down to about 18,000 rows, and that's a lot. So sometimes you have to, this describe just helps you get a picture of what if we are working with. For example, the easiest function here we can see is max. The max is just going to get the maximum value from each column, and minimum, the standard deviation, so on and so forth. So from the above statistical summaries, we can see that it has more given us an insight, and that's the good part of a starter notebook. It provides us with everything. So next, we move on to the EDA, exploratory data analysis. So from the EDA, we are able to see uh, visualizations that will be able to more guide us to, so that we know what we are doing and what we are working with. And then the next one here is the outliers. We run the outliers, it's giving us that. So it has explained what the outliers are for and how the outliers are helping here. So outliers are simply those data points which differ significantly from other observations present in the given data set. So this is more of a visualization of the outliers. And then this one is going to be, this is more of giving us this is the geodata from here. Then the next part now is we're going to run this part now. This is should be from the okay. So this cell is running. So now that this cell is done running, if you are from Lusaka, this map can look very much familiar. So as we can see, this is basically the map of Lusaka, and we can see some blue tracks there. The yeah. So if you're from Lusaka, you can be familiar with this. So this is more also helps us. The EDA, the exploratory data analysis, just helps us get more of a glimpse of the type of data that we are working with. So now we're going to run this part now, the second cell in the in the starter notebook. Also run this one. Okay, so we have another visualization of a roundabout across Great East Road in Lusaka. That's something like that. So basically what we'll be seeing here more of exploratory data and the data set that help us get insights for us to be able to create our model, or I'll just more say fine tune the model. Yes. So as you can see, these are visualizations from the data set. So here this is the morning rush hour and the evening rush hour. So now what we are going to do here is now check for the missing values. So as I said, if you're running if you're just doing this without a starter notebook, you'd have a lot of problems trying to just, check for missing values, try to fill in those missing values and things like that. So here, this is now a visualization for percentage of missing columns in the data set. So if you have this access to this, you're going to have, you have access to this note starter notebook. You're going to notice here the insights from the data set. I'm going to read one of them. Most of the times we are no cars at midnight. So we are able to tell from the EDA. And at midnight, it makes sense. At midnight, almost everyone is sleeping, and this is Yango, which is more of like business and things like that. So meaning that not really much people are booking Yango rides in the night. Then now we're going to check for duplicates that brought back false, and then these are some, this is now for the top 20 correlations features to the target. And then this is now even a bigger visualization. Oh, no, just made a mistake here. I was supposed to run this one first. That this one has given us a problem. So just just a second. I just tried to fix this. Just stop sharing my screen just for a minute. Not a minute, just some few seconds. Okay, I can see something in the chat. Okay. Okay, so my screen should be sharing. So notice that this part wasn't really, it's giving us an error to run here, and this is in the starter notebook. So sometimes this can happen in the starter notebook, but well, as well, everything, the hard work has literally been done for you, and most of the times you just have to focus on the model. So I'm just basically going to fix this part just quick, and we'll be able to see the correlations. Yeah. So this is basically, these are basically the correlations, top 20. Then now this should be able to work as well. Yeah. So now this is now more of a visualization of the correlations, as we can see. And it's how many correlations here? Okay, so the feed size 13A there. So now we move to the part that basically more of like the primary focus should be kind of on. So when we get here, this is now the modeling part. So in the modeling part here, I'm just going to just explain a few things, but first I'm going to run this cell. I'm going to run this cell. So now as the cell is running, what we can see is that some sort of feature engineering has been done here. So from all the columns that were in the train data set, this is the train data set. So the columns are these that are at the top here. These are the columns, the ID, the days, and things like that. These have been dropped. The ID has been dropped basically because sometimes the ID is just something that helps us find a certain point. So in this case, it has been dropped because it won't be that much necessary for the model, as well as also these others have been dropped, as well as target has also been dropped because the target is what is going to help us create the model. So we can't train the model without, we train the model basically without, basically for the X is basically the values we are going to be putting in. So when you put in the values in the X, it's going to output, give us the Y, and the Y is the target. So you can't give out the target and then the target comes about because that's what we are looking for. So in the first place, it's like us saying we don't have it yet. and then we now get it out of what we do there. And then now we move to splitting the data into training and testing the data set. So you're going to have this basically in the starter notebook, but for the sake of explaining, as this part is still running, we are going to the X train, X test, but I'll focus mainly on these things here. So what's happening here is that we are splitting the data into two parts. So what we have done here is you can see the test size is 0.3. In this case, this means that we are just going to use 30% of the data set for testing, and then the other 70% for training. I think if I don't know if I've explained that one properly. Just to confirm, Yasin, am I correct? Okay, so Stephen, you can speak.
Yes.
Recording in progress.
Yes, yeah, you're correct. So when you're splitting the data, you're splitting between the test and set. So what's this? Zero, is it 0.3? So 30% will be used for testing and the 70% will be
Okay.
used for training. So in this case, others go to the extent of actually even putting the validation set. So we can either split it into two, or we can split it into three. Depends which school of thought you come from.
Yes. So, so as you heard, that's what this is more of like doing to the data set. And then, if you can remember, when we had started, we added a seed for us to be able to produce the same values, because what happens sometimes is randomization if there is no any seed that has been put in place. You might be getting different values all the time and all the time, meaning that if you give the model to someone else to use, they will receive other detail. They'll get basically different predictions from the one you got. So the seed is an important aspect of this. So the model that we are using in this case, and it has been initialized, is random forest regressor. So as you can see, the seed has also been put there, and as well as the jobs here. So I will make predictions and we'll also get the RMSE score. This score is something that helps us to evaluate the model to see whether this model is working right, or is just to see how much better it is compared to other models. We'll get to that. So it managed to run. Now what we're going to do is run this next part just below. So this is the feature bar chart showing feature importance. So as you might be running, maybe there might be times when you're trying to improve your model and you say stuff like, you might just say maybe these ones which are not important are the ones which are affecting the model performance. So you just come here to the expert, to this part that's written X here, and then add those that you think are not working, and they'll be dropped, and your model will basically run. So now the next thing we're going to do is make predictions of the test set, creating a submission file. So we're going to run this, and we see that the submission file has been created, but it hasn't been saved. No, yes, it hasn't been saved for us to now take it to Zindi. So now we will click here, and it has managed to run this cell. We've just run this cell, and you notice that immediately after we run, this name here is what's going to be, I have just changed the name, but basically the name that's here is the one that is going to appear on the files here. So what you're going to do is click these three dots, and then when you click the three dots, we download the file. So the file is currently downloading, and it has just finished downloading. So we are going to come to the practice challenge, and what we're going to do is click submit. So now as we have clicked submit, you're going to choose a file. So this part here written daily is showing us how many submissions we can submit in a day. And then the total is the limit of submissions we can make for this challenge. You can also add a comment on the first submission. So in this case, I'll just add a comment to show. So this just helps you know what this was the first submission you made, this was the second, in case you use the different model here and stuff like that. So we will choose the file, and this is the baseline submission file that we created from the notebook, and then we'll submit. As we submit, the platform will start to score us here to see what score we get. So basically, this is the score that we have gotten by using a random forest regressor model here. So now sometimes you would like to change models to be able to see how they differently affect the model, or just to not even get in that much deeper. We talked about the test size to say we are only testing 30%. So we can also try to see what happens to our RMSE score when we when when we just put the test size to 0.2, either if it's going to perform better or if it's going to perform lesser. This is just even before you think of maybe having to change your model. And then also something about Zindi is that when you're done and then you are, let's say, in the top 5, you are going to have to submit the notebook that you used, so that they're able to validate the model and see if you followed the rules and everything. So something that I would recommend is after you manage to run that, let's say you're in the top 5 or whatever you are at, you can find when the competition is now done and the private scores are now shown, you find you are number 10, now you are number 2. So I just recommend you copy this part of your model, and then you can get a notebook. You can get a notebook or something, or notepad. In my case, I'm using a notepad, or even sticky notes is can be a good alternative. Okay, it needs an update, so we want to be able to use sticky notes, but we can simply use the notepad, or just anything where you're able to just put the details. So we can just come there and just save this as you can save it as your this was the first submission, because sometimes you'll be number 1 or you're in the top 5 and then you're asked to give back to send your model, and then you find that in the process of you having to have tried doing different things, you've now messed up everything, and now find the you can't find the model that you used. So, and in that case, when the people at Zindi now try to run the model and notebook, all that they will now come to find is that everything is different. And in that case, if you are number 3, you'll be penalized. You now move back to the position based on what your notebook is given. So it has managed to run here, and we can see that at first this was the score that we got, And then now we have gotten a big RMSE score. So now that we have gotten a big RMSE score, we are going to see how this affects the model that we have created. So I'm basically now just running the same things again, but what I'm going to do here is I'm going to change this part here because this is the name of the name of the submission or prediction file that is going to be created after we run that. So I'll say this case, I'll just say test size 0.002 because that's what we basically did. We just changed the test size there. We didn't really change anything much. So when we do that, it has managed to run, and we should be able to see a test size come here in some few seconds, and yes, it has come here. So we are going to download this. So just to take a note of this score here, 1.9 was better than the one that we have received here. So basically when we come here on my submissions, we should be able to notice to say that this new one that we have created is so far different to the first one that we had used, which was in the starter notebook. So I'm going to submit it. You can see it's even now showing that I've submitted one. So press choose file, test the same one that we got, run it here, and then we submit. So it's now scoring us here, 2.7. So now when we come to the leader, oh, it has actually performed better than the first one when I expected it to be the other way around. So you notice that we didn't really have to change the model or anything. We just had to change the test file to the test size to see how the model is going to perform. And in this case, you see that it actually performed better than the baseline. Because as for the baseline, you can see that this is the score that it gave us. But now, after doing some few things around here and there, we got to this score. But what we did wasn't really tough, but it's all about trying just different things. Sometimes you try all the models out there and it might not give you everything, and you just change the test size, and here we go, everything working. So how the test size might have worked in this case, just to give an example of what this test size more of like really means, since as Yasin had said, this is the point, it's more like we are saying that we test, in this case, it's 20% of the data, and then we use the 80% of the data for training. So in this case, what's happening is that we are using 70% of the data to train the model, and then just 20% for testing of that data. We can't put a value here like 1 to test like 100%, test the data 100%. It's more of like when, in simpler terms, when you're going to school or something, what your teacher or the lecturer will do is they will give you uh, some percentage of things to learn on. Maybe your book, the books you have contain 30%. In this case, I'll say 70% of what you need to pass the exam. So now what you're going to be doing is you'll be training yourself on that 70%, and then meaning that you haven't seen 30% of what is going to come, because that's the test now. So after now you're done training with the books that you have been given, now the test now the test will now build up from those what you had learned. Now you're seeing new things, and then now you're implementing on the new things. That's what happens here. So if we put something like 100%, what will happen is a case of something that we call overfitting, where we give all the data, and now if, for example, the same example I said, a student at school. So what usually happens if you are given all the data, and then the test now comes different from is okay. The best example I'll give is, for example, there's a saying to say that when you get leakage or information like that, your focus will be just on the leakage instead of what is in the paper. So if you bought leakage from somewhere and then you enter the exam room, and then you were training yourself over that data that was given to you, and then you now find the test is different. Now it's going to be total chaos, because your head, you just had the information about that leakage. Now you're lost and you don't know how to go about the process. So in simpler terms, that's what, using examples, that's what overfitting simply means. So now another thing that I'm now going to do here is I'm going to run a different model to see how it's going to affect the score, and see how we are going to be able to run that. So this model that I'm going to do is it's a simple, it's basically a simple model, and this is more of the first models you start with, and it's helpful in some certain aspects of data science. For example, in your, okay, let me not confuse much. So the name of this model is called linear regression. So I'm going to run using this model, and then we're going to see the type of prediction, the type of score that we are going to get after we run this different model. So what we're going to do is import in. So we'll just come at this part and then just change what's written here. The, I feel like I have removed something. Okay, that's not real much problem. Yeah, so see, f is equals to, yeah, regression. Yes, so now I've put in the linear regression. So if you can recall, the first model that we used was random forest regressor. So that's why I said sometimes it's good to just have something where you'll be able to keep what you had used at first, because sometimes maybe the first one is the one that helped you, and now you're number one, and then now the competition is closed, and then now it's closed. You don't know what you had used on the first one. So basically, we're going to now run uh, this one for linear regression. So this one has been run fast. Linear regression is not a big model as it's not as big as the random forest model. So we can see that the RMSE score, which should stand for root mean squared error, is 3.3. So now let's see the type of score that we get when we run this model. Oh, I've already run it. Just okay, linear regression has no attribute to feature importances, but in this case, our main focus is trying to get the submissions. So this one we use linear regression, so we can just change the name of the file to say linear regression one, because maybe after this one you might fine tune the linear regression model. So you just put 2, 3, 4, 5, 6, and like that. So we will now run this one. Now that that's run, it should appear here in a few seconds. Okay, so it's here. So now we'll do the same thing. We are going to download it and see whether it's something that's going to give us what we are looking for. So linear regression 1 and submit. And then it's going to start scoring. So we can see that this one has poorly performed, unlike the first ones. Unlike the first ones that we started working with. This one hasn't really gotten much. So even when we go back to the leaderboard, you will find that it's not appearing here, and you'll be able to see this. So in this case, you can see Chikondi here also ran the notebook, and he got to that score, and it has created the leaderboard. So something like this will be created based on the scores that we are going to get. So if you can notice, I can tell from this one is that he ran the starter notebook just like we had done on the first one, and then this is the score that he got, and then we further on what us we did, which was different from this one, but we also did this one, is that we just changed the test pattern, ended up just getting just a bit more, just a 0.002 better than the first one. So it's not even really much a big change, but it can be a big change if the hackathon is really stiff and you really want it can be a big change. So you can notice that the one with this score is better. So hence it's number one, and then the one with this one is two. So that's how the leaderboard works. But you're going to notice that when it comes to time for the hackathon. Let me just see what I'm sharing because I feel like, oh, it's sharing this. So what you're going to notice is that when we start the hackathon, we are going to have the public and the private score. So those two, they've got a way that they work. I think if you're seeing from Ubuntu AI, can more give us a glimpse of how the private score and the public score work on the leaderboard. Okay, so if it's not there, we can easily just on the Zindi platform, we can be able to tell the difference between the public score and the public score as well as the private score. So when we come here, this is just another Zindi challenge. So I'm more of looking at for the rules. Okay. So I'll take a lot of time looking for the rules, but I know a bit of the difference between the public score and the private score. So the public score more of like just accounts for a certain percentage of values in your submission CSV. So it hasn't necessarily said that what you have put in is the right things. There are sometimes you might be number two when the hackathon is running. But now the private score, it gives more of like the full percentage now. It allocates for all the values that you have in your data set. So you'll find in the public score, the score that you had was less, or so to say. Yes, you're going to find that it was less. And then immediately after the private score, you find better, or either you've gone down. I've seen people, they were number two, and then when the private score is now given, not, I mean, the public score is now given to everyone, you come to find now you're number 46, but you were on top there. So there are a lot of things that go around when it comes to such cases. So here what we're going to do now is we're just going to go back to what we had done at first. But in this case, we are going to be using the best model that worked for us. So as you can recall, I said it's best to copy for everything. And if we are trying out different models, you can be just adding to my dash points like that. And then you can say hashtag, this is for linear regression. So for linear regression, we'll do the same thing. We'll just get that part. So see, because sometimes you find the one for the linear regression is the one that has been performing good, and at first it didn't perform well. On the scores, it didn't, because that score was only accounting for a certain percentage. So we'll just have to paste that. So okay, you can go ahead.
Okay, thanks very much. Yeah, so as you're talking about school, and you had asked a question about the private and public school. So ideally,
Yes.
in machine learning, there's a concept of overfitting. So overfitting is basically when you tune your models to very much align with the data. So it's very much close to the actual data. And when you feed it with new information, the predictions might be bad, or the model will generalize bad because it was more accustomed to the data that you were using for training and testing. So what happens is in the backend when you submit your model, as the competition is happening, you are presented with the public score, which is basically what you see as the competition is running. But then they also want to test how well your model is generalizing on. So remember, I'd spoken about uh, train, uh, train tests. Then I said, depending on which school you come from, there's validation. So in this case, you'll be training the model and then you'll be using the validation, which is now your test data. And then what the model is going to predict, that will be now the more like a public score. But then there's now data which the model knows nothing about, even if you've never seen before. That would be now your actual test data. So now, what's the output of that test, which was hidden completely, is going to produce? That would now be your private score. So that is mostly what is used to determine if if the final score now. Like, okay, so it's not automatic that when you're leading the public leaderboard, then you're going to win the competition. But then your model also has to be tested on other data, which is the private other data which you've never seen, which then now becomes like your private score. So if your model is consistent in terms of like producing good results, then uh, you would have won the competition if you're still leading. So that's what is mostly considered. I hope I've tried to do some justice.
Yes. Yes. Okay, yeah, so basically that was an explanation that how the public and private schools work. If you can recall, I failed to give a proper explanation of how those two work. So I hope everyone was attentive and able to hear the difference between those things and how sometimes you might even get confused. You were number 3 and now you're number 10 when the other one comes out. So basically that's how it works. So if you had seen something came here saying that runtime for the notebook is done, so I'm not sure. Runtime is disconnected. Okay, it's back. Everything is working. Okay. So yes, so what I said here, if you can recall, I said now let's just try to remove a feature from here and see how that feature is going to how that feature is going to have impact on the predictions that we are going to make. So if you can require, I'd say that it's important sometimes just to have the other models that you had created at first. So we will go with this first model here, and then we'll put it back. But in this case, in the process of putting it back, we are going to change something here. So what I'm going to do here is just going to be something real quick. So what I'm going to do is I'm just on this part. What I'm going to let me not really complicate much things. Let me just go direct into looking at the train data set. So let's just try to remove this this part of the column to see how it's going to affect the model. So what we're going to do is just add this part here to drop. But in most cases, you're going to have to sit down and research on other tools that can help you to know what to remove, what to add, and how to go about some certain things. Just a tip: there is a library for SQL that helps you work with feature selection, but it's also just assuming, and sometimes you just have to go through proper data preprocessing techniques as well as visualization to see what's necessary and what's okay. So I'm going to add that feature that we got from let me go back to that feature. Yes, this feature from the train file. So it's not able to copy. Okay, let me copy it from up there, then add it. Yes. So this is basically the same random forest model, and we're going to see how it's going to affect the scores. Sometimes the scores might be the same because it's not really much difference that we created, but let's just try to see how that goes. Because as it's running, because as some things might work, you find that maybe in this case we included features which weren't even necessarily adding value to the model. And in most cases, such features might be there if, for example, when you're trying to remove, when you're working on a data set and then you notice that it's got a lot of missing values and things like that. Sometimes in most cases you have to just if it has got maybe just some if it has got some sort of data and then they are missing values just here and there, you can use techniques to add the median there or the mean to fill in that space. But sometimes when it has a lot of missing data, it's just better sometimes. I've said sometimes it's just better to remove that column instead of wasting time and trying to create estimations. So this part here on trying to work with the features here for the feature engineering to see what to drop, what to add is what's going to necessarily help us to see whether is this working well, is this not, was this even needed in the first place? Because maybe from this one that I have dropped, we are going to realize that in the first place it was the model that we were even supposed to use. It wasn't supposed to be necessarily there. So it's just taking some. Okay, so it has managed to run, it has given us that score. Now let's sort of see how that one is going to perform. as opposed to the one that we did. So the feature names should match those that were passed during fitting. Okay, okay. So what we realize here is that when I added this feature to this part here, it's now created confusion because in the test data set, this was more likely, and now it's not there. So it says the feature name should map as fitting the feature names and seen at fit times. So for this case, there are basically a lot of things that we'd have to follow. And this is a beginner workshop. If I get into detail now, us trying to change things fitting here, when the goal was just to help us see how we can create our first submission for a notebook. That would more confuse everyone. So in that case, what I'm just going to do is I'm going to remove this part. And then I want to now focus on why the seed is important. So when we come to most Zindi hackathons, it can be any, uh, all of them. The first rules that you see when you come to a Zindi challenge is add the seed for so that we can be able to reproduce the same predictions almost everywhere. When we come to the description, it's going to say something somewhere to say add a seed. The rules here, the marks there. These are basically the rules. Sometimes you might use a model. I remember in the first course, someone talked about using auto ML, but in the rules here, there's a point that will more like help you to say it will give insight on the type of models that you can use. So you can see this part is even highlighted because it's very important and to prevent randomization of the prediction. So reproducibility of submitted code. So your code should be able to reproduce. So one thing here is we notice that this one, the linear regression model, ran faster than these others. These others took long. So I just want to see how the RMSE score here will be changing because we don't have a random state. Just want to focus on that. So what I'm going to do here is I'm going to remove this part return random state, and we'll see what happens each time we run. So for now, we have the numbers 2.024, 2.024. So I'm then going to just add that on top and say hashtag. Let me even zoom in. Yeah, let me zoom into this code so that everyone will be able to see. So hashtag, we got 2.024. So now we don't have a random state there. Let's see what we get. So now we have gotten 3.35. Let's keep that number. So when we keep that number, we'll say 3.35. Let's run it again, and we'll see the importance of having the seed. So you see that now the score is 3.0951, which is different from the first one that we got. So that's basically what will keep happening if you don't add the seed to your code. We run it again, you see it has given us a different RMSE score. That's what will just keep happening. So the score is here. We run it again, different. Run it again. Okay, I think I have, okay, see. We run it again, we will notice it's going to be different. Again, it's different. And look, so we have just seen 3 plus this one here, 4 different RMSE scores, which can potentially affect the model. As you can see, we are measuring the accuracy of the model, and we just have now random values that keep coming and going. So now what happens if those random values you got, they worked well right there, and you even submitted to Zindi, you submitted your score to Zindi, and let's say perhaps that even worked well for you. Even the private leaderboard, it manages to work well for you. And then now you're asked to submit your code. And then when you submit your code, this time, instead of bringing a better value like 2.4, it comes to bring 3.09. So in that case, you won't be at the position where you thought you might be. Yes, so that's why the random state is important. And in fact, this value here is for the basically the first random state that we got. So the random state will add it back and then equals seed. So now that we have added the random state back and the feed is just right, the seed is just right at the top. When we started, this was the seed. We said seed is equal to 2023. So now let's try to run it with a seed in place just to see the difference. So you see 3.35. Again, we run it 3.35. So the model basically here is now just giving us the same thing, the same thing. And then now this here is now proof that even if we were to hand it to someone else, or even if you're following along and you copied the exact same things that I've done here, you're probably going to get the same score. So meaning that even when you send your notebook to Zindi, to the Zindi authorities to check whether to see is this machine learning model valid, you will now be able to get, they will be able to get the same score and say, ah, wow, this has worked. And just like that, you'll be able to move along. So that's more about the importance of having the seed there. And then when we come to the model here, you notice this part in the brackets. I won't really get much deep into it, but when we put in values here in the bracket, those values help us to more just fine tune that model a bit. So just for the sake of showing, I'm just going to go on Google and search, since that's a linear regression model, just a linear regression model. Okay, in the you can speak.
Okay, no, you can, so you can continue. Then we also just give our attendees a chance to also ask questions. So some of the things maybe you are talking about, they might be spoken to when responding to some of the questions. So that then it's not just only you speaking at this moment, but then also we've got our participants also asking questions and you're trying to address their questions. So if you, to the participants, if you've got a question, just feel free to raise your hand up and then,
Okay,
or you can type your questions in the chat. Thank you.
okay. So just see the. Okay, so yes, in case if you have any questions, you can go ahead and proceed to ask the questions in the chat, and then this can be also so much better if you're following along just on some other device and trying to see if it's going to work or not. If you realize that the first I said this is a hands-on practice, this is a call to action. It's more of like almost the exact same things that we are going to be doing in the hackathon. We change the test size to see how it's going to affect the model. We change the model, and yeah. So in this case, I talked about this part here is that in most cases it's where we add the parameters. So I'm going to just say on Google linear regression model parameters. Yeah, so it's best to go to scikit-learn library because the model is from scikit-learn. Yeah, that's why when we look at the code here, we are saying from sklearn. It's coming from here. This is where almost all the models are found. So this is now a documentation for linear regression. So we are now left with 4 days to the hackathon. But if you just someone wanted to sit and just see how these things can affect the model and how they can make your model proceed and what they mean, this will be the best part. You just look at the documentation to see how some things work. So as you can see here, they've just done almost what we did. But our focus mainly for us is the parameters. So when we come to the parameters here, we come here to the jobs parameter. So what I'm going to do is I'm going to just get this. We'll come here and we'll put it inside, and then we'll say is equals to 1. So I'm not really going to explain much here. As I said, when there are 4 days left to the hackathon, so these things have got deep meaning on what they mean, and some might even have a mathematical aspect of it, so it can just cause some confusion. So this was the score that we got without a parameter. Now we have added this part to the linear regression model, and then all models have got parameters. And you might be saying, why are we still working with the linear regression when random forest worked better? In this case, we're just doing that because the linear regression is the one that's able to run fast. Because if we were doing random forest here we managed to run this model almost 6 times now. Linear regression maybe would have been now running the third model. So now I'm going to run this and see how it's going to 3.35. So even after putting this parameter, it has given us the same thing. So let's just put a parameter which is outside, which can try to create a big difference. Still the same thing. So okay, but basically the concept is there are some models that have got a lot of parameters, and these models are basically the reinforcement models that you can also just come to Google and search for examples of reinforcement learning algorithms. So we are going to be I wanted to give things like maybe if I get two images, we'll find something. Okay, I don't want it to get to too much detailed things, but examples of reinforcement models are models that you're going to find them. I think random forest is also an example, if I'm not mistaken. So basically, there are reinforcement models. You find models like XGBoost, and those might be the ones that will even get you to where you want it and stuff like that. So just not to even go that much further. I don't know if I don't know if everyone here had watched the first workshop that we had. In the first workshop that we had, it was simply a notebook by Sitwala Mundia, and then in this notebook, the model that he used was he used the model and he added other parameters from something it's called Optuna for high parameter tuning. And this is something that might be beneficial for you guys just to take a read and see how this or help will help you to create a better model when it comes to there. Because what will happen now is that now let's say it's 5 hours from the competition, you've tried to run all the models that you can manage to run, and then now you the main focus will now be on fine tuning your best model. Now you start trying to change the parameters for this model, trying to see how things go like that. And in the first case, we had used a random forest model. So let me just check here. So random forest is under ensemble, and these are also other models. And you see all these models, and you'll be able to see how you can use them. So when it comes to random forest, you find it has got these parameters, the n estimators parameter, then it just simply means the number of trees in the forest. Just take a look. You can, okay, yes, you can speak.
No, no, it was just a mistake. Thank you. You can continue, Lighten. It was a mistake.
A hand pass run and things like that. So I guess for today, if you manage to get into today's meeting. Thank you to everyone who managed to get into today's meeting, and we hope for the best on Saturday.
All right. No, thanks very much, Lighton. Again, is there any questions from our participants, our attendees? Is there any question before we close that you'd want Lighton to address, something that you're not clear about? One, two, three. Okay. We don't seem to have any questions. So, the tutorial will be live on YouTube by tomorrow morning. So in case you want to go through this over and over again, you are more than welcome to do so. Uh, Again, to win these competitions, it's a matter of practice. So the more you practice, the more you make reference to other people's work that people have done, the new models that are coming out on a daily basis. There's quite a lot of technical terms that Lighton was making reference to, which it might not be possible to explain each and every technical term. So the more you interact with this, the more obviously you begin familiarizing yourself with some of these terminologies. And again, the more research you do, the more you find better models to work with. So thanks very much for taking your time to participate, and thanks very much, Lighton, for putting this together and for sharing your knowledge. We wish everybody the very best, and we see you virtually on.
In his back, yes.
Yes, I'm having intermittent network connection. So yeah, I think that's it. We can close now and see you on Saturday. Thanks very much, Light.